limit of a function. And the method I'm going to be using here is going to be the direct substitution method. If this is your first time visiting my channel or watching my video, don't forget to like, click on the subscription button, and don't forget to drop a comment in the comment section box below. So let's see the first question I'm having here. The question says, evaluate the limit as x approaches 0 of function x squared plus 5x plus 9 divided by 2x squared minus 3x plus 15. Now in this video, I'm going to be making use of direct substitution. So what I'm going to do in this case is actually to take the limit, or let me simply say find the limit of this function. So let's go ahead and do that. So from the limit rule, I'm going to have limit x tends to 0 of x squared, right, plus 5x plus 9, then this divided by what, 2x squared minus 3x, right, then plus what, 15. Then here I'm going to have limit. I'm going to take the limit of both sides actually. This limit x tends to 0 of the first one, then I can basically have limit x tends to 0 of the second one, right? So that's basically what I'm going to have. Since I'm using direct substitution here, I don't need to waste my time, but just go ahead and replace all the value of x with 0, since it's a direct substitution. That is, our x approaches 0. Then we take x to be 0 here. So we're going to have this to be 0 squared plus 5 into bracket 0, then plus 9 divided by what? We're going to have 2 into bracket 0 squared minus 3 into bracket 0 plus what? Plus 15. Now since I've already substituted all the value of x with 0, what I'm going to do now is just to go ahead and simplify it a little bit. I'm going to have 0 squared to be 0 plus 5 into bracket 0, which actually is what? Which is 0. Now I'm going to have here to be equal 9 divided by 0 squared is 0, so multiply 0 is what? 0. Then here as well, I'm going to have minus 3 multiply 0 is what? Is still 0, then plus 15. So I'm going to have plus 15 here, right? So I can go ahead and simplify this fraction a little bit. So here I'm going to divide both sides by 3. I'm going to divide the numerator and the denominator by 3. And in that case, I'm going to have this to be 3 divided by what? 5. So the limit of a function, of this function, as x approaches 0 is actually what? Is actually 3 divided by what? 5. Now let's go ahead and solve another question. So now let's take a look at the question I'm having here. The question says evaluate limits as x approaches infinity, or you simply say undefined, anyhow you like, of 5x plus what? Plus 1 over x. So in this case, since we are having a single denominator here, we can actually go ahead and separate, so that we're going to have this to be 5x, right, divided by what? X plus 1 divided by what? X, right? So that's exactly what we are having here in this case. So from there, we're going to have everything here to be cancelling each other. So and this is going to be 5 plus what? 1 over what? Over x, right? So if we are using direct substitution, we are going to substitute our x to be this infinity, and that shows that we're going to have 5 plus 1 divided by what? So and there is a rules when it comes to limits, that whenever you have what? Limit x tends to what? To infinity, right? Then over 1 divided by what? X. So in that case, you're going to have 1 divided by what? Infinity, which actually what? 0. So that shows that everything we are going to be having in this case is going to be equal 5 plus 1 divided by what? Infinity. And that's going to be equal 5 plus 1 divided by what? That's actually what? 1 divided by, that's basically 0. So the answer is going to give us 5. That's just it. So that shows that 5 is what is the final answer. Now let's go ahead and solve another question. So let's take a look at this question that I'm having here. The question says evaluate limits as x approaches 3 of x squared plus 9. So using direct substitution, this question is actually very cheap. We're going to have this to be 3 squared, right, plus what? Plus 9, right? 3 squared is actually what? 9 plus 9, and that's going to give us what? 18. So this question is somehow cheap, right, because it's very simple. So let's go ahead and take a look at the next question I'm going to have here. In this case, you can actually try the question out. You can go ahead and pause this video and see if you can actually try it out. So let's go ahead and solve this question. We're going to have this to be limits x approaches 0 of what? 3x squared, right, then plus 3x cubed, rather, plus 2x squared, right, plus x plus 1, right, divided by, we're going to have this to be x is power of what? Of 3 plus 2x, then plus what? Plus 5. So from here, I'm also going to have what? The limit of what? As x approaches what? 0 of this value. So the next thing I'm going to do is actually to go ahead and use direct substitution. And if I'm going to use direct substitution, let's see what I'm going to have in this case. I'm going to have this to be what? To be 3 into bracket 0 raised to the power of what? Of 3. Then I'm going to have plus what? Plus 2 into bracket 0 raised to the power of what? Of 2 plus 0, right, plus what? 1 this is going to be divided by, we're going to have this to be 0 raised to the power of 3 plus 2 into bracket what 0 plus what plus 5. So at the end of the day, we're going to have the final answer here to be what 1 divided by 5 using direct substitution. So you go ahead out and divide all the both sides by the highest power of x, which is x power of 3. You might not end up having what is it called? You are going to have math error actually, right? So that's exactly what you're going to have. So you're not going to have the right answer than you using what direct substitution method, and you're going to have your answer to be what 1 over 5. So let's go ahead and solve another question. Let's take a look at another question I'm having here. It says evaluate limit x tends to infinity of 4x squared plus 3x plus 2 divided by 2x cubed plus 5. And in this kind of situation, we are going to make use of direct substitution, right? So let's go ahead and see what we are going to have here. So from this question, we can basically say we have limit x tends to infinity of the first one, which is actually 4x squared plus 3x plus 2, then divided by, here we are going to have limit x tends to infinity of, this is going to give us 2x to the power of 3 plus 5, right? So using direct substitution, basically we are going to have this to be equal 4 into bracket infinity squared, right? Then plus 3 into bracket infinity, right, plus 2 divided by, we're going to have 2 into bracket infinity cube, right, then plus 5. Now what does infinity means? Infinity simply means a very large number, right? It's a very large number. That's basically what it means, right? So we are now having 4 multiplied by infinity squared, right, plus 3 multiplied by what infinity, then plus 2. Instead, we are going to replace this by what by 0 actually, because infinity is a large number, right? So then we can just basically represent as 0 because we are having it, right? So from here we're going to have 0 squared plus 0, right? Then we're going to have plus 2, right, divided by what, this is going to be what 0 cube, then plus what 5. So the final answer here is going to give us 2 over 5, right? And the reason why we are having it like that is because whenever we are talking about infinity, the limit of a function is actually not defined. Whenever we have what infinity, it is not defined, and in that case we are going to replace it with what, with 0, because whenever we are finding the limit of a function, we basically want to find a definite value, a defined value for the function, right? So that's basically what this means. So this particular function is defined at a point where we have the function is equal to 2 divided by what 5, right? So now let's go ahead and solve another question. So let's take a look at another question that we have here. So we are asked to find the limit x approaches to of x squared plus 2. So using direct substitution, this question is actually direct. So if you apply direct substitution, you're going to have this to be limits, right, x approaches to of x squared plus limit x approaches to of 1, right? So in that case, whenever we have limit x approaches to of a constant value, this will give us the constant value, which is what, which is 1, and that's exactly what I'm going to write down. I'm going to have 1, then plus, here we have what, a value here, right, a divine value which is actually what, 2. So limit x tends to 2, that's going to be, I'm going to have this one to be 2 squared, and at the end of the day I'm going to have this to be 4 plus 1, and that's going to give me what, 5. So the limit of what, of this particular function is actually what, 5, right? So that's basically what it means. So I think that's going to be the end of this video on that limit of a function using direct substitution. So if you enjoyed this video, don't forget to like, share my videos, and at the same time click on the subscribe button. So in the next video I'm going to be focusing on factorization method and rationalization method. So that's just about this video. If you enjoy it, thanks for watching.